Good day. I am Professor Ricardo Naraha, your professor in EST1, Basic Electronics and Sensor Technology. Today I will discuss to you the resistor color coding. Resistor color coding is a coding system that uses colored bands to easily identify the resistive value and percentage tolerance of the carbon resistor. In carbon film resistor, there are two color coding bands, the 4 bands and the 5 bands. Before we start the conversion, let us first determine the different equivalent numerical value of the different color codes. Black is equivalent to 0, brown is 1, red is 2, orange 3, yellow is 4, green is 5, blue 6, violet 7, gray 8, and white 9. These color values are good for the first and the second digit value of the color codes, while the third color band signifies the value of the multiplier for the first and the second digits. Black is equivalent to 10 raised to the 0 power or times 1. Brown is equivalent to 10, red is times 100, orange is times 1000, yellow is times 10,000, green is times 100,000, and blue is times 1 million. Gold is times 0.1 and silver is times 0.01. The fourth color band is for tolerance, that uses 4 color bands. Brown is plus minus 1%, red is plus minus 2%, gold is plus minus 5%, and silver plus minus 10%. Now let us start converting color codes into numerical resistance value. Here is our example. We have color bands brown, black, red, and silver. This is how we will read the value of the color codes of a resistor. The first color band is brown. This is equivalent to 1. The second color band is black, which is equivalent to 0. The third color band is yellow, which is equivalent to 4, but this time, as a multiplier, this is equivalent to times 10,000. The fourth color band signifies the tolerance color. Gold is equivalent to plus minus 5%. Therefore, the value of the color code is 10 or 10 times 10,000. This will give us an equivalent to 100,000 or 100 kiloohms. Now we will compute and convert the value of the color codes, which is brown, green, and brown. So this is the actual resistor having that color code: brown, green, and brown. Okay, so this is the picture, and this is the actual resistor having a color code brown, green, and brown. So now I will use the analog multimeter or the VOM for the resistance measurement. But first, let us have first to compute for the value of the color codes written in the body of a resistor. So the first color band is brown. The second is green. And the third is brown. Brown is equivalent to 1. Then green is equivalent to 5. And the third color is the multiplier, which is brown, which is equivalent to times 10. The fourth band is gold, which is equivalent to plus minus 5%. So from here, we are going to solve for the 5%, a positive 5%, so as with the negative 5%. But before that, we are going to solve first for the value of the resistor. It is 5 times 10, that will give us 150 ohms, and the tolerance of plus minus 5%. And then, we can get now the positive 5% by adding 150 plus the 5% of 150. Where are we going to get the 5%? We have to compute for the equivalent 5% from the value of the resistance. So, we have 150 multiplied by 0.05 will give us the equivalent of 7.5 ohms. So now to get the positive 5% of 150, we have to add 7.5 to 150, and the negative 5% will be subtracted from 150 to get the negative 5%. So the positive 5% is 150 plus 7.5, that will give us 157.5 ohms. This is now your positive 5% of the tolerance. To get the negative 5% tolerance, we will be subtracting 7.5 from 150. So 150 minus 7.5 will give us 142.5, which is our negative 5% tolerance. This means that the 150 ohms resistor will operate from the actual measured value of 142.5 up to 157.5 measured value of resistance. Now let us measure the actual resistance of a 150 ohm resistor using the analog multimeter. So this is the actual analog multimeter that we are going to use to measure the resistance of a 150 ohm resistor. So this is a separate discussion on how we are going to use the analog multimeter to measure the actual resistance value of a color-coded resistor. First, we have to set the range selector to our desired range to be used in the measurement. For now, we will be using the X10 as our desired range. So as you can see, the range selector is set to X10. Now you short the test leads, then adjust the 0 ohm adjuster to set your ohmmeter to 0 ohms for an accurate measurement. Then now we can now proceed to the resistance measurement. So the needle pointer of the BOM stayed between 10 and 20, and that reads 15. So 15 times 10, which is our range, that will give us a reading of 150 ohms. This means that the color code 150 ohms is equivalent also to the measured value, which is also 150 ohms. Now I am going to show you how to measure the resistance using the digital multimeter. So this is the digital multimeter. First, I will set the range to 200. There, as you can see, it is now set to 200. Then I will turn on the illumination knob so that the screen will be seen clearly. There you can see it displayed OL, that means infinite. Then we short the test leads and it reads 0.1, which is almost equivalent to 0. Then proceed to the actual measurement of the resistor, and the reading is 153.3 ohms. So the color code value is 150 ohms. However, using the positive tolerance that we have computed, the equivalent positive tolerance is 157.5. So 153 is still good for this resistor. And the resistor is still in good condition. So that's all for today. Thank you very much. Good day.